Howdy folks, we're out here in the garden and we're pulling out the edible soybeans, or the edamame. This is what they look after they're picked, and these are the plants. And what I noticed on the plants were these kind of nodules on the roots. And I've read about the nitrogen fixing plants, and there's a number of beans and peas and legumes in general will actually take nitrogen from the air and convert it into forms that can be used in the soil. And I think that's what these little nodules are on the roots that I've noticed. I don't know if you can see that okay, but there's some larger ones and some smaller ones. So I thought it might be interesting to actually try to analyze that in the lab. So what I'm going to do is I'm going to take a bunch of these off a certain weight, and I'm also going to take out a certain weight of roots and a certain weight of the green parts. And maybe I'll actually look at another plant or two and look at the concentration of nitrogen in each of those different areas or samples. I would think if these are nitrogen fixing nodules that they would be definitely have a significantly higher amount of nitrogen in them. So that would be interesting to try. So I'm going to take some of these in the lab and we'll give her a try. Use a little hose off to get the dirt off of them. Alright, that's actually pretty clean. Warning, warning! I have to put out a disclaimer here. I'm doing this just as a fun exercise. The science and methods involved here I'm just pulling out of thin air, so take everything with a grain of salt. These were those nodules, and they're actually root nodules. They're not true rhizomes. And what happens on the root of the bean, there's a root hair, and it gets infected with a bacteria called rhizobium, or rhizobium. That's it. Which causes more confusion because it sounds like a rhizome, but it's, like I said, these are actually classified as root nodules. So anyways, we have this to test, and I also have some of the roots of the bean plant, and I have some of the beans to test, because I read somewhere that actually the growing the bean legumes doesn't really add a lot to the soil, because the nitrogen just goes up and it goes into the bean, and then the bean is harvested. So maybe we won't find a lot in those root nodules, but we'll see. This is just some of the leaves in the roots, or I mean in the bean plants, and this is just a small potato and root stuff. So we'll try a whole different plant and can see if there's any nitrogen or nitrates or ammonia in there. So the first thing, I saw a couple methods for extraction, and basically what they say to do, well actually there's a bunch of methods. A lot of them use dried material, and some of them use fresh. And so we're going to use the dried material method. But you're supposed to grind it up and sieve it. I'm just gonna put them through a chopper and chop them up. So there's a couple different solutions that you can use to extract the ammonia or nitrates, and one is actually potassium chloride, a 2 molar solution. Another one is actually acetic acid. Another one that's mentioned for fresh material, if you have green tissue, is methanol, and I think another one is salicylic acid. So the simplest of those seems to be the potassium chloride solution, 2 molar. So we're going to go with that. I didn't realize today was Sunday. This is a little coffee grinder, and I bought it at a garage sale. I figured it might come in handy someday to grind some samples up or something. And I guess today is Sunday, so I'm going to start with some of this leafy material because I have a lot of it. And I'm not sure how this is going to work, but we'll put some of that in there and grind it up a little bit. Okay, it seems to be floating around a little. Well, actually, it's doing all right. We'll throw some more in there. Wow, that looks pretty good. We've got one leaf in here, but the rest is a pretty fine powder, if you can see that. Alright, here are the rhizome sort of materials, actually the root nodules. I think that's the limiting quantity here. I don't have a lot of that. And plug that during cleaning so I don't chop my fingers. Okay, that's the root nodules. Well, I guess it's a Molinex coffee and spice mill, and that worked out pretty well. Good for small samples too. Now we're going to weigh out our material, and I think the weak link, or the material that we have the least of, is this nodule material. Most of the methods call for well less than a gram, like 25 or half gram. I'm going to see if I can get a full gram out of here. That's a gram. Alright, so we have a gram of the nodule material, and I'll put this in our hillbilly beaker, and I'll go ahead and weigh 1 gram quantities for each of the other materials here. I don't know if I mentioned, all this material has been air dried thoroughly, and this is the last material. This is the potato. Okay, we're good to go. Now we need to make the extraction solution, and I decided to use potassium chloride because I have plenty of it, and most of the procedures use something like less than half a gram of the dried material or thereabouts, and less than 25 mils. So for a full gram, I'm thinking of using like 50 mils per sample. So since there's 5 samples in a blank, that's 6 times 50, so I need about 300 mils worth. And actually I could be a little bit shy on the blank, but 300 mils should work. So to use 2 molar potassium chloride, there's 2 moles. KCl per liter by definition. And the molecular weight of potassium chloride, potassium I think is 35, chlorine is, chlorine is 35, potassium is 39, so that's 74, so there's 74 grams of KCl per mole. Okay, so the moles cancel out. So now we have grams per liter, but we don't want a full liter. We only want about 300 mils, so that's 0.3 liters. And the liters cancel out. And if we do the math, it's 44.4. Okay, so it didn't come out too clearly. It's a little more than an ounce. I'll weigh it in here. And this is no salt, and it's pretty close to being pure potassium chloride. There's some other additives, and actually I've done a purification of it for some other applications, but for this one nothing's going to really interfere that's in here, and they're very, very small, minute quantities. Okay, that's all of our potassium chloride. I'm going to add about 300 mils of water. Alright, here's about 300 mils. So that's pretty concentrated, and that may be that way to actually osmotically pull out some of the nitrates, but I really don't know. So we'll let that dissolve. Looks like I have a little bit of the anti-caking agent on the bottom here from this no salt potassium chloride, so I'm going to just filter that real quick before we use it for the extraction. I don't know if you can pick up on that, but it's definitely filtering clear. So pretty much all the methods say to actually shake it, add your extraction solution and then shake it for 15 minutes in a shaker. I don't have one, but I do have a stir plate here. So what I'm going to do is I'm going to mix each one for about 10 minutes, and they're going to sit for a while the other ones do their thing before filtering. So 10 minutes and a long wait should work. So let's get this thing moving. Alright, so there's the first one. Let's move that to the side. I'll get the other ones filled up while we're waiting. I can see why the procedures use a shaker mechanism, because a lot of this stuff kind of gets up on the side of the flask, and every now and then I kind of wash it back in. But if they're in a shaker, you wouldn't have that issue. I'm doing a filtration with a kind of a perforated cup here, funnel, that I'm lining with my coffee filter material, and have it on top of a funnel going into a container here. So I'm going to try to get as much of this as I can into the filter. Well, this is going exceedingly slow, so I'm going to switch to an actual kind of a mesh screen with the coffee filter liner, and we'll see if this speeds things up at all. Just going to be a slow process, especially without a vacuum assist. As you can see, I have stuff filtering all over the place here. That's what I hate about filtering. It seems to just take so long. That's why I always try to centrifuge when I can. This is the final step. This is the rest of the extraction fluid, which acts as the blank. So I'm running it through a filter just like everything else, and so that'll give us something to compare it to. Poured a little bit of the material off into a test tube, so I'm going to run them through the centrifuge to see if that will settle out any more or not. Well, I got these centrifuged. They're still cloudy, but I centrifuged them for quite a while at a really high rate of speed, and the tubes are actually a little warm. And it didn't get them clear, but it did take some material out from the bottom there. You see stuff that has definitely settled out, so that's good. I think it's good enough for us to at least take a look at the test here. The nitrate test that I'm using is from this vintage water testing kit. If you haven't seen the video, I did do a kind of a review on it, but it does have these nitrate reagent pillows and a testing unit here. You fill this with your sample, you add one package of the chemicals, you shake it up, and you compare it to the color on this side. And this is a graduated scale from 50 down to 5 parts per million. And you see this is really dark. I was getting some real dark results. So I looked to, maybe I needed to dilute it, but I actually just put in distilled water. And even with distilled water, deionized water, I'm getting this really dark color. And I think the reagent is bad. Who knows how old it is. It's quite an old kit. And when I do cut open the reagent package here, let me cut one open. Certainly are hard to get open. And you got to kind of squeeze it open. Nothing, it's kind of all caked in there. Very little comes out. You have to really work it. And this one's actually better than most, but it seems to me that the reagent is bad. So unfortunately, I'm not going to be able to do this nitrate test on this project. So anyways, that's too bad. I thought I had a solid nitrate test, but I guess I'm wrong. I made a 500 ml ammonium solution with ammonium chloride, and I'm going to dilute that down 100 to 1 to get a 5 part per million solution. So that'll give us a reference solution. The nitrate test was a bust, but I know this test method works. I've done it before on a water testing application, and actually it worked out really great with the colorimeter. And I tried different standards and blanks, and came out beautiful. I'm not going to use a colorimeter because the turbidity on these are going to be will get in the way, but I don't think it's really needed either. We're just going to eyeball and look for differences here. So I changed the order of the samples. This is actually the blank, or number 6, and this is the standard, that the 5 parts per million, and then we have the nodule, the rootstock, the bean itself, the leaf, and the potato. So for the procedure, we're going to take 2.5 mils of each of the materials, transfer them to these other tubes, and for each 2.5 mils you put in 1 drop of 1 molar sodium hydroxide that I have here, and then you add 1 drop of this ammonia test solution that I got from a pull test kit. So let's go ahead and get started with that. And here's the last sample, 2.5 mils. And now we need to add 1 drop of 1 molar sodium hydroxide into each. Give each one of those a little bit of a shake. And we'll add a drop of the reagent. And we'll give each one of those another quick shake. Let's take a closer look at our ammonia results here. This is the blank, and I don't see any color at all, so that's good. So that went through the process, same reagents, no color. This is our standard. This was the 5 parts per million, and you definitely see color there. So that's good. Our test is actually doing something. The next item was for the root nodules, and we expected to see quite a bit of a change there if there's a lot of nitrogen going on. At least if it's in the form of ammonia, we would see it. But maybe it's a little darker as compared to the one on the left here. Is actually, we didn't add the reagent. This is the one with the reagent added to it. So maybe a little bit of color, but boy, not much going on there. The second item was from the root itself, and that doesn't look like it has any color. There's the original extraction without the reagent in it. So once again, maybe a little darker, but not much going on. The third item is from the leaf, I believe. No, the third item is actually from the bean. So I would expect to see a lot of ammonia there. And actually I do see a little bit of darker color compared to that. So the bean seems to be actually accumulating the nitrogen, just like I read online. So that's interesting. And the fourth was the leaf. And looks like a fair amount of nitrogen in the leaf too. It's hard to tell because, you know, it definitely looks darker, but we're getting the green color from the chlorophyll that probably was extracted with it. So it looks like we have some in the leaf also. And now let's look at the lowly potato. Yeah, we see some in the potato too. Well, this didn't turn out as well as I had hoped. The nitrogen test, which was going to really, I think, be the most pertinent indicator of the amount of nitrogen that was fixed or in the material, was a total flop. I had the seal reagent pouches, and I thought that they would be good, but they're quite old and obviously weren't any good anymore. So that was a bit of a disappointment. Now there's some other nitrate tests that I could do, like the brown ring test, but with my experience, you need quite a high concentration, and it's not really quantitative, so that didn't work out. So I also did the ammonia test, which hopefully would kind of correlate with the total amount of ammonia fixed too. And that test worked out well. I've used it before, and the blank came out negative, totally clean, and the standard definitely had an indication. But the results were a little bit different than I expected. The nodules themselves actually didn't show hardly any, if any, ammonia in there. That same goes for the root material, no ammonia. But we did see some in the bean material, and that kind of collaborates with what I read online, that the nitrogen doesn't really accumulate in the nodules. It goes up to the bean where it's accumulated. So the legume as a nitrogen-fixing crop is a little bit not as good as you would expect, because you harvest the bean and most of the nitrogen in the process. It also showed that the leaves had a fair amount of nitrogen. I don't know if that's the case, because some of the color from the chlorophyll that got extracted might be in the way, but something definitely showed that there was a lot of nitrogen in the leaves. And last but not least was the lonely potato, and that actually showed a lot of ammonia. I thought that would be pretty devoid of anything else besides starch and water, and fiber, but it did show some ammonia there. So anyways, that's it. I'm not sure what to think about the results or the test method. It wasn't an exciting conclusion, so hopefully my next ones will be a little bit more exciting than this. Well, if you're still here, thank you for watching this long. That's really something, especially when the analytical testing doesn't come out as well as I would have liked. Anyways, thank you so much for watching again, and good luck to you with all of your analytical lab testing and experimentation.